Welcome back to the Abaris Training Podcast. I'm your host, Michael Herzer. Today we are here with our guest, and he's our former president of the company Abaris as a whole, Mike Hoke. We're going to be talking about his career in composites, a little bit about how Abaris came to be itself, just some fun stories in between.
Okay.
Yeah.
Well, thanks, Mike. I appreciate it. We're both named Mike, and I'm ready to talk about any subject you want to bring up. Let's just get going.
Awesome. Well, first, I guess, where did your composite career begin?
Well, it's kind of fuzzy, but when I grew up, when I was a teenager, my father ran a flying school, and he had another business, which was a photography business, separate. But so I kind of grew up in the flying school, and I learned how to fly gliders when I was 14 years old, which is the minimum legal age to fly a glider solo. And back then, this is in the 1960s, they were mostly made out of aluminum and fabric covering and steel tube and things like that. But in the 70s, the Germans started building high-performance gliders, which became to be known as sailplanes. They're much higher performance. And they started with fiberglass, which, of course, is one form of composites. And so I got into fiberglass sailplanes in the 70s, and they quickly, the Germans were among the first to convert to carbon fiber for its higher strength to weight ratio in the late 70s. And I was flying sailplanes all during that time and got involved with some other people that maybe did a little bit of damage, had to figure out how to do a repair, a ding or something. And so just kind of got into it by working with it a lot.
Being around it.
And really didn't know anything academically or technically about it. I just got introduced to it by using it. And that's how I got my first interest. But I never followed through business-wise until I met a gentleman named Bill Murphy, who at the time was working for Bill Lear, who developed the Learjet. Bill Murphy was working for Bill Lear as a plant manager. And the Learjet was the first attempt to build the Lear fan, actually. Bill Lear developed the Learjet in the 60s. In the 1970s, late 1970s, he decided to develop the Lear fan, which was an all-carbon fiber twin-engine turboprop airplane, which was going to be the first airplane ever designed and made completely out of carbon fiber to be certificated by the FAA. That was the plan. And he did that work, Bill Lear did that work in Reno, Nevada, up at Stead Airport, which is north of town. And I did not work for Lear Fan. One of our instructors at Abaris worked at Lear Fan, and another person who became an instructor at Abaris later was Jay Carpenter. They both worked for Lear Fan in Reno, and the airplane finally made its first flight in very late 1979, in fact, the last day of the year, but it flew on December 32nd, 1979, legally.
Yeah, we'll leave that one in there. I like that. I at least want to make a note of that. It is an interesting note that is a legally identifiable and Google searchable day. So if you guys want the story behind that, there's a whole article there on December 32nd.
1979.
1979.
And but Bill Lear by that time had died, and they wound up building 3 airplanes that flew. They got about 900 flying hours on the 3 of them. Never did crash one. They all 3 still exist in museums, but it never became a commercial success, never went into mass production. And the Lear Fan Company up at Stead closed in 1983. So Bill Murphy was working as plant manager for Bill Lear, and he had learned a lot about composites. And he also had, before he went to work for Bill Murphy, he was a U.S. Navy fighter pilot flying off of aircraft carriers, and also as a test pilot for the Navy. And the early F-18 fighters were going in the fleet for the Navy back then, and they had carbon fiber tail services and control services. And they were getting damaged on aircraft carrier use. It's such a tight environment. They're hitting them with forklifts and doing things like that, punching holes in them. And nobody in the Navy knew how to repair carbon fiber.
Yeah.
And the Lear Fan Company, as part of their FAA requirements, had to develop repair techniques and write repair manuals and things like that if they were ever going to be certified by the FAA. So Bill Murphy knew all those, and got some of the manuals. And he decided to start a training company to train the Navy in how to repair carbon fiber damage on the F-18s. And he called it Abaris Training. He didn't come up with the term. He discovered the term Abaris out of Greek mythology.
Yeah.
And Abaris was supposedly could fly through the air and was a healer. He could lay on hands and heal up wounds. And that's why Bill decided to use Abaris as the name of the company, because you're healing up wounds in composites, basically. So
Do you think he was?
That's where it came from.
I don't know. I obviously know nothing about him. I never had the opportunity to meet him, right? So was he real into Greek mythology, or did he just kind of stumble into it?
He just kind of stumbled into it.
Interesting. So another kind of question I've had real quick off of the first part of the conversation, which was gliders. When we're talking about performance in gliders, what are some of the things that they look for? Meaning, what measurements are we trying to achieve? Are we trying to achieve a longer glide time? Are we trying to achieve a further distance?
Well, all of the above. The basic measure of the performance of a glider is what it's called its glide ratio, which is how many feet forward it can go for every foot of altitude it loses.
Okay.
In just a straight glide in calm air.
Oh.
And the low performance gliders tend to be around 20 to 25 to 1. High performance gliders these days can get as high as 70 to 1.
Wow.
We're 70 feet forward for every foot down.
Yeah.
Or if you look at it in terms of miles, for a mile of altitude, 5,280 feet, you can glide over 70 miles in one of those things with no lift, no weather, no nothing. But what they do in actual flying, you try and find thermals where you climb up and hot air columns, warm air columns, the same way that hawks and eagles and buzzards, you see them circling and climbing. They're climbing in a little rising column of warm air. And there are other ways too, atmospheric waves, which you can get very high altitude. Unpowered gliders have flown to over 75,000 feet, which is as high as the SR-71.
Wow.
Almost.
Wow.
They went to like 80. But you have to have the right weather phenomena. If you don't have the right weather phenomena, nobody even flies you. You don't fly them because you can't get anywhere.
Yeah.
So they're very, very weather dependent.
That's interesting.
But all the modern sailplanes are built out of carbon fiber, just almost exclusively.
Yeah.
So anyway, Bill Murphy, when Learfan closed, Bill Murphy decided to start Abaris Training to train the Navy and how to repair the damages on the F-18, which he was quite familiar with. And it gradually grew from there, and he started getting other customers from other than just Navy, from other military branches initially, and then started getting civilian customers, and it just gradually grew. And so he started it in Reno in 1983. I knew Bill socially, but I didn't work for him at the time. The company I worked for eventually got sold, and my job got moved to Minneapolis, and I went up there to see what it was like in January.
Yeah.
And came back and said, no, I'm not moving to Minneapolis. It was brutally cold up there.
Yep.
And so I stayed in Reno, became unemployed, went and talked to Bill Murphy, and wound up, he hired me in 1987, and I became an instructor. He taught me what I needed to know, more than what I already knew, which was quite a bit, to become an instructor for him. And Lou Dorworth was working there at the same time. That's where I first met Lou. And it just kind of went from there. And Bill and I became 50-50 business partners in 1989. I made a small investment in the company, and we became 50-50 partners. And then he suddenly died of a heart attack in 1991 that nobody saw coming when he was going to teach a class. And so that was a big shock to everybody. And after a year went by and the estates got settled and the lawyers were done and everything, I wound up owning Abaris Training. I purchased his half from his estate. It's what it boils down to.
Yeah.
And I became the owner of Abaris Training in 1991. So I'd worked there 4 years at that point. And so I just gradually kept growing it. We kept adding more types of classes and gradually adding on more instructors. And we moved to the building that we're currently in the winter of 1990, had our first classes in the building on Longley Lane where we still are in 1991, and have just been gradually growing up, we had one classroom in that building at the time. And then a few years later, added a second classroom. And some years after that, added a third classroom just because we were getting more and more students. And the Navy actually still sends people,
Yeah.
but it's a very small percentage of the total business. We get people from the Navy and the Army and the Air Force and the Marines and occasionally the Coast Guard, but almost all of our business is civilian, and a lot of it related to airlines and aircraft repair, but a lot related to manufacturing as well.
Right.
So we get students from companies like Lockheed Martin and Northrop Grumman and just all Boeing and Airbus, you name an aircraft manufacturer, we get students from them.
Right.
Because almost all the new aircraft have not necessarily their whole structures, but a very high percentage of their structures out of carbon fiber. The B-2 bomber from Northrop Grumman's all carbon fiber. The new one they've got out now, the B-21, is all carbon fiber. And so the industry has just gone in that direction for high strength, lightweight, very smooth surfaces, no rivet heads or anything like that sticking out. You can get very smooth aerodynamic surfaces, and it's just the obvious material to use for those kinds of structures.
Right. Right. So yeah, since then, what are some of the bigger innovations that have changed the way that A, we do composites, and B, Abaris as a whole has changed with it?
Not a lot substantial has changed. The main change has been adding new types of classes with new capability. One of the things I had to do starting in 1991 when I suddenly became owner of the company is I had to learn more about composites myself. I had to figure out, how do I learn what's going on, what's new in the industry, in order to even be aware of it, to think about bringing it into Abaris training. So I joined a group called the Commercial Aircraft Composite Repair Committee, CACRC, which is a group run by the SAE, they used to call themselves Society of Automotive Engineers, and then they started calling themselves Society of Aerospace Engineers as well. Now it's just SAE. They say the acronym doesn't mean anything anymore. But they put together this Commercial Aircraft Composite Repair Committee where twice a year people concerned about repairing composites in commercial aircraft, meaning airliners primarily, would get together for technical meetings and have week-long meetings bringing up what's new and what have we discovered, and we had this problem and here's how we figured it out and so forth. And twice a year I went to those meetings, and once was always in the United States somewhere, moved around the country. The other one was always overseas, mostly in Europe. So I would go to London or go to Cologne, Germany, or go to Amsterdam or wherever they were holding these meetings, plus in the U.S. And I learned a lot from those folks. They had different committees, and one was a repair techniques committee, how you physically do repairs. Another was a repair materials committee, what you do the repairs with. Another was non-destructive inspection. How do you inspect the damage in the first place, figure out how big the repair has to be. And then after you repair it, how do you inspect the repair to make sure it's going to work properly. And so I had all these different committees. One of the committees was repair training. So that's a committee that I joined, but I went and attended other committee meetings. And I met some really good people, really smart people in composites through that committee. And probably the most important of they were all important, but the most useful to Abaris person I met was Ginger Gardner, who at the time was Ginger Gupton. She wasn't married then. And she worked for DuPont and was the Kevlar and Nomex expert for DuPont. DuPont makes Kevlar fibers and Nomex fibers. She was very knowledgeable and really involved, and wound up becoming one of the 3 authors of our first main textbook.
Right.
And also contributed heavily to the second edition of that textbook a few years later. Lou Dorworth was one of the other main authors, and one of them was a former instructor named Greg Mellema. But Lou and Ginger did the most of the work on the textbooks, and the textbook was just excellent, in my opinion. It became an industry standard textbook. And of course, we gave textbooks to all our students. Every student that came to class got one of those textbooks as part of the class. And You can also, it's got an ISBN number. You can buy them from Amazon if you want. But it's really a well-done textbook. And so we started adding more technologies as we learned about them. And right now, the big challenge is to get into thermoplastic composite structures as opposed to thermoset composite structures, where thermosets, like with epoxy resin, the resin starts out basically as a liquid. You mix parts together, and it cures up at certain temperatures and times and pressures and becomes a solid. And that resin is used to impregnate the fibers, carbon fibers in most cases, to give you a strong part. Now we have thermoplastic composites where the resin melts when you heat it up and solidifies when you cool it down. And that can happen very quickly. If you can, as fast as you can heat it up and as fast as you can cool it down. So you can, with the right kind of equipment, you can make a part in a couple of minutes instead of several hours for a cure cycle on a thermoset part.
Right.
But the hard part about thermoplastics for us is by their inherent nature, it's difficult to get a good adhesive bond to them for doing repairs. They're great for making initial parts, but they're not so good for if you have damage and have to do a bonded repair as opposed to a mechanically fastened repair. It's really difficult to get a good bond to thermoplastics. And there's a lot of work going on in the industry right now about how to do that, and how to do surface preparation, and how to get a good bond on thermoplastic repairs. And that's the latest change up in the technology that Abaris has to follow and get into where we can teach classes in that. Right now, there are no classes in thermoplastic manufacturing and repair, but that's the next step to come. And Ginger now works for Composite World magazine. She's their senior editor, and she's been writing lots of articles about thermoplastics over the last several years. So now that I'm retired from Abaris, I would suggest that Abaris go to her to try and get to the information they need to put together thermoplastics classes that would be useful to the students. The thermosets aren't going away. This is just sort of a new level of technology we have now that it's going to be very complementary to the thermoset structures we have now. Thermoplastics are going to add a lot, and they're already showing up in airplanes already. Thermoplastic structures.
Right.
So that's the next biggie that I see.
So over the last, that sounds about accurate to me too, especially since we took that seminar, that webinar, you, me, and Corey, I think it was 3 or 4 years ago now. But yeah, that was a pretty good eye opener there. And that we've talked a lot about that in-house, and that's one of the things we're working on currently. Throughout the entirety of your career there, what would you say is the single biggest advancing tool? What tool has been brought to our attention, or process has been brought to our attention that has just completely game changed, has been an obvious step above how we used to be doing composites? What's kind of evolved there,
Well, it's of course evolved very slowly and changed over the years. We have better non-destructive inspection techniques now than we used to, for example. Although the old inspection techniques still work quite well. The biggest change is the one I just talked about. It's the thermoplastic. That's just a whole new arena of materials and processes that we have to get into. And in any composite, both the material itself and the process by which you manufacture the part or do the repair are both equally important. And it's really material and process engineering. It's not just materials engineering.
Right.
And thermoplastic processes are very different than the thermoset processes. And that's where we got to go. We've added smaller incremental changes as we get new classes. For instance, some years back we added a class in metal bond repairs, bonding aluminum to aluminum primarily, steel to steel, other metals, but primarily aluminum because that's mostly what's used in aircraft structures. Because there was enough demand from our students, even though they were working on composite structures, most airplanes still have a tremendous amount of aluminum, and they're having to repair that as well. So bonding, adhesive bonding, where you apply some type of adhesive and cure it in some fashion and have to have some surface preparation before you apply the adhesive, it happens in both composites and metals. So we started a metal bond repair class just to to go into that niche of the industry, I guess that you would call it. Technically, it's not composite related, but practically it is. The same people that do the composite repairs are doing the metal bond repairs.
Okay. Yeah.
So,
Yeah.
So interesting. So,
Yeah.
and I could go on forever talking about composite repairs to metal structures. That's been done too. There used to be a military transport called the C-141, which is a big 4-engine transport, is all aluminum. And the entire fleet of those was saved from grounding by metal bond repair techniques using boron fiber composites. But it's a real technical little thing, and I think it's just above and beyond the scope of this.
I was going to say, I don't think we need the
I got
whole
involved
breakdown,
in that.
but yeah.
And one guy at Warner Robins Air Force Base in Georgia now named Bill Schweinberg literally saved the entire fleet of C-141s from grounding with that technique.
That guy's the hero of the day then.
Well, yeah, he's unfortunately gone now, as I understand it. And the fleet later got retired anyhow when the C-17s came on.
Oh, yeah.
They replaced the C-141s, but they gained probably 10 years of useful life where they literally would have been grounded forever without the repair he developed. So very difficult, really cool, time-consuming repair.
Yeah.
So,
and on that note, that was one example of somebody seeing a problem and overcoming some adversity in the industry. Over the years, what is some adversity that has faced you?
Well, the main adversity is never having the funds to expand as much as we wanted to, having to do it all out of our earnings, which is very, very difficult in a small business. We never had any investors or anybody to put in significant amounts of money. But I guess the second worst thing that happened to us, the first worst thing I'll talk about in a minute, the second worst thing that happened to us as a company financially was about 2010 or so when the government put in this thing called the sequester, where they're having budget problems. There was a big slump in the economy then.
Okay.
And tax revenues went way down, and the government had to save money, like billions of dollars. So they put in this program called the sequester, which basically stopped all the military from spending anything except what was absolutely necessary that they could not do without on the moment. And the first thing that got cut was training.
Yeah.
They stopped all their training literally overnight. Wow. It went away. And military was about 50% of our business back then. And it just went away. Boom, gone. And stayed gone for about a year.
Yeah.
But they couldn't go without it forever. So it gradually started to come back in. And finally, with the presidential election of 2012, I think the sequester got dropped about 2012, 2013.
Okay.
And it came back. But that was a difficult time for us to just survive financially. But the worst time was when COVID hit. When COVID hit, we went from the best year we ever had financially was 2019.
Right.
COVID hit early 2020, and we closed completely in March, shut down completely, stopped all training, and didn't have any income at all until we gradually reopened over the summer and gradually started bringing students back in. And so there's literally zero income coming in. And so the only way I could save the company was take out a large bank loan against my house to be able to save the company, which I did. And we gradually got back up. The business slowly increased as COVID more and more faded into the background. And now it's back up to pretty much normal as far as number of registrations go. And so that was, nobody saw that one coming. That's just out of the blue. How do you plan for that? So it was an interesting time.
Yeah. And not only did we have to shut down, but leading into that, traveling obviously becoming an issue for people, that takes a hit on us, especially since the airline industry as a whole is such a big equation, or such a big part of that equation for us. that all those travel bans and everything that was happening beyond us reopening was still kind of
Yeah.
hindering us gaining our footing again. So it was a little difficult there.
The hit was practically overnight. The recovery took months and months,
Yeah.
many months, to actually gradually get out of it and get back to kind of to normal now, I think. So those were the two big things. There were other little ups and downs.
Yeah.
September 11th was an interesting event, but didn't really hurt our business much at all.
Another one that I kind of want to ask about a little bit is what was, we don't need to go down the whole story between what happened here, but we were not always in the Longley building. We were at one point on the other side of Parr, right?
Right, Parr Boulevard. Bill Murphy's did two things. He did production, trying to do production composite parts and sell them to small companies. He'd build 50 of this and 40 of that. He was never really able to make a success out of that.
Yeah.
But he was trying. And the other part was training. So when we became 50-50 business partners, I took over the training. He kept the production, and I moved the training to Longley Lane.
Okay.
Because we needed a better building for training. That old building was really bad. It was real cold in the winter and hot in the summer and very crowded and so forth. I just had to have a better place. So I moved the training to Longley Lane. He kept the production going up in that building until he had his heart attack and died.
Oh.
And then they vacated the building. Somebody else has the building now. It's still there and still using it.
So if there's anything off that you could think of over the 40 years of us being open as a company, if there have been any missed opportunities, like something we should have got on board,
Yeah, I'm sure there are, but I'm not sure that I have a clear understanding of what those opportunities were, because otherwise I would have tried not to miss it.
Right. Right.
I'm not sure what those would be.
Yeah.
We did try and expand into overseas training. We opened a place in the United Kingdom, in Wales, in a building that was occupied by the German airline Lufthansa, of all things. And Lufthansa had a division of Lufthansa called Lufthansa Technical Training.
Okay.
And they contracted with us to come in and do composite training in their facility in a little town called Cwmbran, Wales, which is about 30 miles north of Cardiff, Wales, which is the capital of Wales. So it's kind of an out-of-the-way location. I don't know why Lufthansa ever picked that in the first place.
Yeah.
There's no airport there.
Oh man.
But anyway, so we went in there and taught in Wales on a regular schedule of classes. And then Lufthansa decided to move out of Wales, and they moved to a different city in the central part of England, whose name escapes me at the moment, another small town. I can't remember the name. It was near a town called Cirencester, but that wasn't it. Anyway, it doesn't matter. They moved their operation to a place that did have an airport, and we moved with them. But after the move, we were just never getting enough students. We'd go over there, fly somebody to England and teach for 2 weeks with, maybe 3 students in class.
Yeah.
And we just never could get good class sizes, and we finally just shut it down.
Yeah.
And I actually don't know what happened to that Lufthansa Technical Training building at that point. So we tried that. That didn't work very well. I think had I done a better job with marketing that somehow, we could have made a success out of it. However, that kind of rolls us into on-site classes, because we do a lot of classes overseas. Anyhow, I personally did classes 2 weeks in northern Norway, about 160 miles north of the Arctic Circle.
Oh, wow.
In a town called Bodø, Norway. I did 2 weeks there for a Norwegian regional airline called Widerøe Airlines, which was a very interesting place to be. And it was in May, so late May, so it was almost midnight sun thing. It got dark about 11 o'clock at night and got light about 1 a.m. in the morning.
Wow.
And wasn't quite, June 21st is when it would have been the most light all the time. And the weather wasn't bad. It was in the 40s in the daytime temperature, not frigid like they would be in the middle of winter. But it was an interesting place to go visit. I never would have gone to Norway otherwise. I've done classes in Singapore several times, which is another fascinating place to visit. I love Singapore. I go back there in a heartbeat.
Yeah.
But boy, it's expensive,
Oh yeah, man.
and it's hot and humid.
Yeah.
And it's an island
checks
60
out.
miles north of the equator. It's going to be hot and humid.
Yeah.
and and
A little different than the Arctic Circle.
and
right?
they air condition their buildings within an inch of their lives. Their buildings are freezing, and they like it that way.
Yeah.
And every time I would walk outside, my glasses would fog over.
Yeah.
Get out of the air conditioning into the humidity. But a lot of interesting things in Singapore, and I've done classes personally. I've done classes in Malaysia, many different places in Australia. Germany, Cologne, Germany, at the EASA headquarters. EASA is the European Aviation Safety Administration. It's the European equivalent of the FAA
Right.
for the European Union. And I've done a number of classes in Cologne, Germany. They're actually two different buildings there. They were in one building and eventually moved it to another bigger building in Cologne. And I've done classes in those places. And many other places in the United States and Canada. We've done classes all over. But as a company, I don't know. I used to keep count of them, and I finally gave up after it was like 100 different locations
Wow.
on site we'd done classes. I used to have a big map on the wall with pins in it.
Oh yeah.
Finally, we took it down when we built the third classroom. We needed that wall.
Yeah.
But it was
that's what that map is there.
Greg Kress, our engineering classes, just went for 2 weeks in Turkey.
Right.
For Turkish aerospace engineering, and they've sent people over. The only places we haven't done classes, we've done classes in Japan and other places in Europe. South Africa, we've done classes in South Africa. We've done classes in Dubai, in the United Arab Emirates. Places we haven't done classes and almost certainly never will are China, anywhere in mainland China, and the Soviet Union, never done anything there. And those kinds of countries where we have obvious political issues like Iran and Afghanistan and places like that, we've never done classes and likely never will, at least not for a long time.
Yeah.
Of course, during World War II, we never thought we'd do classes in Japan or in Germany.
Yeah. Yeah.
Of course, we didn't exist in World War II, but you get the idea.
Yeah,
Things change. Things
Yeah.
change over time.
Yeah. Definitely.
So, yeah.
Yeah. It's an interesting thought, though.
So,
That's for sure.
anyway.
Yeah.
So, what
And
else?
on the other side of things, so we also do have a little bit more consistent other spots for us, meaning we have our other facility in Brazil that we have our
Right.
instructor handle out there. And then we do have it's kind of like our sister company, not really, but we work with KVE out in Maastricht. How did those kind of come to be? Meaning either one of those, Brazil or Maastricht.
Well, the one in Maastricht began when I was at a commercial aircraft composite repair committee meeting in Cologne, Germany.
Okay.
And at that meeting was a gentleman, a Dutchman named Harm van Engelen.
Right.
Harm van Engelen. And he came up to me during one of those meetings and asked if he could have lunch with me. So we went to lunch. And he owns a company that was called KVE Composites that does a lot of composite work, and especially in thermoplastics. He's really big in thermoplastics. And he wanted us to provide training in thermosets for the normal repairs in the Netherlands. And we wound up setting up, and they have an aircraft mechanics training school where they teach mechanics how to work on regular airplanes, not composite related. And we went into that school and got a classroom and got a little workshop, and were able to do composite repair training there on a regular basis.
Wow.
During COVID, that all stopped.
Yeah.
And I don't believe it had renewed itself, at least not during the time I was still at Abaris. It may have since then. I don't know.
That I know of, it hasn't, but you know,
But that's how that
no
one
reason
got
for it.
started.
Yeah. Yeah. Okay.
And the one in Brazil, in Sao Paulo, the initial connection came from Hecon Composite Systems.
Okay.
Hecon makes hot bonders and heat blankets, which are used heavily in composite repair. And we started using Hecon equipment many, many years ago. In my opinion, it's the best equipment on the market for that. And their South American sales representative, Fernando Ricardo, came up to Hecon, sent him to Abaris to take composite repair training classes.
Okay.
And so he came to Abaris, took classes, and that way he could better help his customers in South America who were buying hot bonders and heat blankets to use them.
Yeah.
And Fernando wound up suggesting that he start his own training center teaching our kinds of classes down there on a kind of a 50-50 basis. I don't think it's really 50-50 anymore, but I don't know the details. But he started that many years ago, probably 15 years ago now.
Yeah.
I'm not really sure, but that's how I got started, through the Hecon connection. So he still works for Hecon.
Yeah.
And works with us on doing training.
I did not know he still worked for Hecon. In fact, I didn't know he worked from Hecon to begin with. So this is all news to me.
As far as I know, he still works with Hecon.
Wow, that's super interesting. I did not know that.
Yeah.
And,
he's a great guy and really does a good job with the training.
Yeah.
One of the things I regret is I've never gone to Sao Paulo to see his facility.
Yeah.
I want to go down there. I may do that now that I have some more free time. I might go to Sao Paulo.
That'd be really cool. That'd be awesome.
Yeah.
And besides, like I've been saying, there are worse places to go for a week of training than Brazil.
That's true. So, Sao Paulo, yeah.
Yeah.
I would go down there during Carnival, probably a little crazy, but other than that, it'd be good.
Yeah.
But
that's cool.
That relationship has worked out very well for many years. Fernando's a great guy.
Yeah, he sure is.
Yeah.
That's interesting. I did not know he came from Hecon. That means we've had 2 instructors who are former Hecon employees, or one maybe current. That's right. But still, wow, that's interesting.
One of the other big, not changes we made, but a capability we gained, although we didn't change out of anything, was to start offering engineering classes at the engineering level that requires a degree in mechanical engineering or structural engineering to be able to understand the classes. And we started those classes in the late 1990s with Greg Kress, when I hired on Greg Kress as an instructor. And he got his master's degree in composites from the U.S. Naval Postgraduate School in Monterey, California, when he was active duty in the Navy on aircraft carriers. And they sent him to that school, and he got his master's degree. And he has developed a number of different engineering classes in advanced composites, which now have, in my opinion, have set the standard in the industry for those kinds of classes. And
I agree.
They are deeply mathematical in nature. And your first day of class, he's got 5 different classes now, I think. First day in class, you're hip deep in calculus and matrix algebra. And you really need to be a degreed engineer to be able to comprehend the class.
Yeah.
And I remember some years ago, the Navy sent a guy to class to take one of Greg's engineering classes. So Monday morning, he came in, put him in the class. First break, about 10 o'clock, they took a break. He came out and came to my office, and his eyes were as big around as saucers. He says, "I don't have any idea what's going on in there. I have no clue."
Yeah.
And it turned out he was a Navy composite repair technician, and the Navy had accidentally signed him up for the wrong class.
Oh, yeah?
And we didn't know that, and he didn't know that till he got in the class. So fortunately, we had a phase 1 class, which is what he needed running that week. So we just, mid-morning, we swapped him into the phase 1 class.
That's
and
good.
Then he was good from then on. Yeah.
Good. That's lucky. Man. Yeah, because the other nice thing about that, though, on the kind of other end of that spectrum is Greg's classes also give the engineers a good chance to actually get in there and play with a lot of these materials. Oh, yeah. And that is very fun to get to experience with them.
He is big on hands-on training for the engineers. He absolutely insists that the engineers get their hands dirty, and they build parts and vacuum bag them and cure them and break them and test them with their own hands. And they love it.
Yeah.
A lot of them have had all kind of composite training in the university somewhere, but they don't get to do hands-on typically in a university environment.
Yeah, so. And I think it really helps bridge that gap on a team, because it's knowing what you do in a role. It just makes everything come so much more full circle, and it makes your job much more enjoyable. So I think it's an excellent course, and I think he's an excellent instructor as well. So good hire there, Mike.
I really lucked out on that one. It worked out well.
Yeah.
So,
and then over the years, let's see. Over the years, I know of about 5 instructors that I've met personally, but I don't know how many instructors we've had totally come and go.
I've never counted them up. And at least one of them came and went and came back, and that was Greg Mellowah.
Right.
And then he's gone again. Well, let me count them up.
Okay, yeah.
There was me, Lou Dorworth, Jay Carpenter, Greg Mellema, and it was about the time I moved the thing down to Longley Lane. And then I had another instructor at the basic phase 1, phase 2 level named Scott Knecht, Knecht.
Okay.
But he left pretty early on in the early 90s, actually. I got Greg Kress at about that same time. Did I count Greg Kress already?
Not yet.
No. Okay, so there's 6. So Greg Kress is number 6. I got Dave Castelar, Mike Maringolo. I already did Jay Carpenter, right? Yep. So Mike Maringolo is 7. We had Lloyd Howden for a while. That's 8. Corey Valenkity. These are out of order now.
Yeah.
Number 9.
And then we have Bill.
Dan is 10. Bill Kynard would be 11. And there was a 12th guy that started out our training in Griffin, Georgia, but he had to move up from Mobile, Alabama to do it. And his wife didn't like the move and made him go back. So he only lasted like 3 months.
Oh, yeah. Yeah.
I can't even remember his name now, but Bill Kynard replaced him in Georgia. Bill was a Georgia boy. So.
Yeah.
So about 12 instructors.
We also had Rick, so 13.
Rick Hesselhurst was another engineering instructor.
I think, yeah. Wow.
Mm-hmm.
Oh, Randy Jones.
Randy Jones, right,
14.
teaches only our NDI classes.
There we go.
He never worked for us full time, but teaches NDI.
Right.
He still does, and he's really good at it.
He is.
Yeah.
He's an interesting guy to talk to as well. And also, one thing I really like about the NDI classes is it's basically a giant discovery museum. He brings all these cool pieces of equipment, technology, and all this, and then we talk about them for a little while, and then you just really get to go in there and just deep dive on all these incredible different pieces of equipment. So what piece of advice would you have for a young individual looking to succeed in the field today after seeing all the advancements in composites?
Well, if he wants to get into the engineering level of composites and design new parts and new structures, he needs to take those kinds of classes, obviously, to get the math that he's going to need. And the basics of composites have been known for many years, and anybody that reads our whole textbook will know most of the basics. But what's the new stuff that's coming down now, in addition to thermoplastics and other new technology, are the really high temperature composites that are often made of what's called carbon-carbon.
Right.
That although there's carbon ceramics and some other ways to do it, ceramic matrix composites that are used in extremely high temperature places like the turbine blades inside jet engines where they're running at thousands of degrees,
right,
glowing white hot while they're operating at full strength, and nose cones on hypersonic missiles and things like that are being made out of ceramic matrix composites and other types of really high temperature composites. And that is the area right now that's probably getting the most attention as something new. Thermoplastics are kind of well understood. We still got a little bit of an issue with how to repair them, although even that's becoming well understood. But this high temperature stuff there's a lot of government money going into research on that.
Okay, yeah.
So if anybody's interested, that might be a piece of the technology to try and follow.
Yeah, okay.
So as we get more and more launch vehicles going, and we're going to go to Mars or whatever, a lot of that kind of stuff, the high temperature stuff is really going to be necessary.
Oh, all right. Awesome. So follow the new technology.
Yeah. And then you could ride with Elon Musk when he goes to Mars.
Perfect. There you go. You'll be his right-hand man.
I swear Elon's really intent on going personally.
Yeah.
I heard him say that he actually wouldn't mind dying on Mars.
Yeah.
He said, but preferably not on impact.
Yeah. There we go. Yeah. So, it's good to have a safe landing there.
Yeah. So you want me to do that story?
Yeah. Speaking of going out into space, let's talk about that one. Huh?
One of the fun things that happened. This is 15 years ago now, I guess. I'd have to go back and look up the date. But it's while the shuttle program was still flying, and we'd had a lot of students from the shuttle program, various parts of it. And it was late on Friday afternoon. It was the middle of winter. It was snowing, was in December sometime. And I was literally going out and getting ready to lock the door and go home. I was the last person there as usual. And the phone rang, and I went back in and grabbed the phone, and it was a guy from NASA at Kennedy Space Center. And he said, "Boy, I'm sure glad I caught you." He said, "I hope you can help." He said, we have this carbon fiber structure that's about 6 feet long and 3 feet wide. It's triangular shaped, got a lid on it. It's got several padded compartments on the inside, and that structure is designed to hold the special tools that the astronauts need to work on the Hubble Space Telescope. And these tools are incredibly expensive. You know, they're millions of dollars, and they got to be protected during the launch and all the G's and all that kind of stuff. So this thing fits inside the shuttle bay and holds these tools. And he said one of our geniuses managed to drop another heavy tool unrelated to this thing inside it when the lid was open and punched several different holes in it. This thing bounced around and punched holes in the thin carbon fiber skins with honeycomb core on this tool holder.
Yeah.
And he said, "We can't fix it. NASA won't let us just put tape on it or something. You know, they can't this is after they'd already lost the first shuttle."
Right.
He said, "We can't do that kind of stuff anymore. We got to have it fixed properly." So what we did was we took it out, we put it on a Learjet, we flew it to California, to Fresno, not Fresno, farther north. I can't remember now. It was a little town south of Sacramento. I can't remember. But the company there is the one that made the thing.
Okay.
He said, it's flying, it's en route, it's in the air flying there now. He said, but we've called them, and they said, well, they can't repair it. They don't know how to do repairs. They could make us a new one. It would take 6 weeks.
Yeah.
And he said it's cost, you know, to have the shuttle sitting on the pad and not launch it costs like $50 million a day or something. It's some
6
ridiculous
weeks out of the question.
amount of money. Yeah. And plus they got orbital parameters they got to meet. And he said, you know, if we don't get this thing launched tomorrow, we're not going to be able to get to the Hubble Space Telescope, and the whole thing is blown, you know. And he said, could you go down there and repair it? He said, it'll be there by the time you get there. And I said, well, yeah, if you could have somebody there at the middle of the night on Friday night, you know, yeah, I could go and take hot bonders and heat blankets. And he described it and sent me some pictures and things to give me an idea.
Yeah, the size you're working on, all that, yeah.
So it was snowing like hell. At the time, I was driving a RAV4, Toyota RAV4, which at least is four-wheel drive.
Yeah.
And I loaded all my crap up in the RAV4 and headed over Donner Pass at night in the snow, and which wasn't much fun. And so it took me a long time, but I finally got there about dawn. And sure enough, there was somebody at the building to meet me at dawn on Saturday morning to let me in.
Yeah.
And I got in there and got a hold of the thing. And I had to do 3 different repairs in 3 different places. And fortunately, I bought several heat blankets of different sizes and so forth. And I was able to actually cover 2 of the repairs with 1 heat blanket and the other repair with a second heat blanket. And I had a dual zone Hecon hot bonder.
Right.
So I was able to cure both repairs at the same time. And got it all done and cured. It was about noon their time by the time the cooled down and we could debag it and check the repairs. And all I could do was tap them, you know, and see how they seemed fine. So they grabbed it up, took it back out to the airport, put it on the Learjet, and went back to the Cape, and they launched it that night.
Wow. All the money they would have lost in that day, you could have set your price.
I could have set any price.
Wow.
And he told me, he said on the call when he called me, he said, I hope you can do this. He said, I'm asking a lot. And he says, we can't pay you. He says, if we pay you, that means we have to go out and get 3 different bids, you know, and go out to multiple. He said, we just don't have time. He said, I can't pay you without getting competitive bids.
Right.
And we can't do that. And he said, would you just be willing to do this out of the goodness of your heart? And so I did.
Yeah.
And he sent me a nice framed letter later, which I have at home now. I took it home because I like that letter. But that's what that was all about. So I feel like I had a small part in saving a shuttle mission.
Yeah, wow. Well, I'd say it was a big part. I mean, if it was going to cost them that much money and they were going to be delayed, they couldn't do this, that, the other. That's awesome. That's really cool. And all just because you happen to be there on a Friday afternoon.
I mean, if he'd literally been 1 minute later, I would never have gotten the call.
Yeah.
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 So
wow.
I don't know what they would have done then. But I'm sure they would have figured out something.
Timing is everything, and the universe is just so random like
Yeah.
that. But that's so
It's true.
crazy. Well,
Yeah.
well, that's been an awesome story, and this has been a great interview. I really appreciate you taking the time to come on and do this for us. Yeah, we just super appreciate it.
Well, I appreciate it too. It's good for me to look back on all these memories. I'm at 75 years old now, and it's good to think back to all this stuff. Had a lot of fun, had a good time, had a few hard times, but it's been good. I can't complain.
Awesome. Well, thank you all back home for listening. This has been our episode of the day, and we appreciate you all. Have a great day, everybody.